Electromotive force or EMF. Electromotive force is the amount of energy, is the total amount of energy provided by a battery to a unit charge, is known as EMF. For example, energy provided by the source, by the battery to this charge to move through this circuit is called EMF. For example, this battery provides 12.2 volt energy to this charge. 12.2 volt energy to this charge to move through a circuit. 0.2 volt is lost inside the source because of the collision with other particles inside the battery, and 12 volt is left at the terminal. So the terminal voltage will be 12 volt. 12 volt left at the terminal. Total energy was 12.2 volt. 0.2 was lost inside the source, and 12 volt is left at the terminal. So 12.2 volt is the total energy, which is total energy given to a unit charge is EMF. The energy left at the terminal is known as terminal voltage, plus the energy lost inside the source is IR. Small r is the resistance of this source, and I is the current. In series the current is same. That's the equation for EMF. EMF is equal to terminal voltage plus energy lost inside the source. You can write EMF is equal to V is equal to IR. Capital R is its Ohm law. According to Ohm law, V is equal to IR. Now, I is common in both its equation for the EMF. Now, I is common in these both. By taking common I, small r, capital R is left. Capital R is the load resistance. Load can be a bulb, a fan, a water pump, etc. Let us consider it's a bulb. Now, capital R and small r is left. These both will divide under the EMF. It's an equation for the current through this circuit. Now, small r is the internal resistance of this circuit. This small r. Epsilon is EMF, total energy given to this charge. I is the current and V is the terminal potential. Yeah, simply you can say potential difference, a terminal potential difference or terminal voltage. Now, EMF is the total energy provided. EMF means electromotive force. Electromotive force is not a force. It's an energy provided per unit charge. Electromotive force is not a force. It's an energy given to that unit charge. Electromotive force is actually not a force. It's the energy per unit charge. It is measured in joule per coulomb. It is measured in volt, which is equal to joule per coulomb. Now, the symbolic representation of this source, this battery, is here. The smaller line represents the negative terminal. The bigger line represents the positive terminal. This symbol, small r, represents the internal resistance of the battery, and this whole is the symbolic representation of this battery. And this represents the load. Load can be a bulb, a fan, a water pump, etc. And the load is denoted by this symbol. Let's consider the load over here is a bulb. Then what happens when these electrons flows through these bulbs and the bulb begins to glow? As you can see that there is a very thin wire inside a bulb. This, as you can see that there is a very thin wire inside a bulb. When these electrons flow through this very thin wire, this is a thin wire as compared to this one, the circuit wire, as compared to this circuit wire. When electrons flow through this thin wire, it collides and the resistance increases. When these electrons collides with the particles at this thinner place, they lost their energy in the form of light and heat. That's why bulbs start to glow in this thinner region of wire. Now, this load is represented by this symbol in a circuit. Difference between terminal potential difference and EMF. Terminal potential difference. Terminal potential difference is the voltage measured across the terminals of the battery. This 12 volt is the terminal potential difference. Terminal potential difference is the voltage measured across the terminals of the battery. And EMF is the total energy. EMF is the total energy provided to a unit charge. A terminal potential is the voltage energy left at the terminals of the battery. And the total energy provided by a source to move unit charge through a circuit. It's the definition of EMF. Now, for closed circuit, for open circuit. Now, first for open circuit. Open circuit means that the circuit is open, means no current flows. Now the circuit is closed. Now the current can flow through the circuit. First, for open circuit, there is no current. For open circuit, the current is 0 and the resistance is infinity. Infinite resistance means current can't flow, means a wire is broken. So, as you know that EMF is equal to terminal voltage plus IR, energy lost inside the source. So, here EMF is the terminal voltage plus IR. So, IR will be minus to the left side. V is equal to EMF minus IR. V is equal to EMF minus IR. Here I is 0. So, when no current flows, means for an open circuit, EMF and voltage are equal. Now for closed circuit. Closed circuit means the switch is on. Now the circuit is closed. A current can flow through the circuit. When current flows through the circuit, the terminal voltage is equal to EMF minus IR. Sorry, it's a small r, not a capital R. EMF minus IR here also. It's a small r. For a terminal voltage. It's not in subscript. The terminal voltage is always less than EMF. When the circuit is closed means when the current flows. When current flows, the terminal voltage 12 is always less than EMF, which is 12.2 volt. EMF total voltage, terminal voltage, the voltage left at the terminals. The terminal voltage is always less than EMF when the circuit is closed. For an open circuit, the current is zero, then the terminal voltage and EMF are equal. The terminal voltage is always less than EMF in a circuit, means in a circuit when the current flows. In a circuit, a special case. The terminal voltage can be greater than EMF when the battery is being charged. When the terminal potential can be greater than EMF when the battery is being charged, then the terminal voltage is greater than EMF. That's all.